as canonical transformation is an important concept. And then, just I told you the three-body problem. Then nonlinear dynamics and chaos, resonance. All this important concept appears. Then this is condensed in the Poincaré's theorem of non-integrability. That is my main talk. And then this related to the chaos, and broken time symmetry. Why in our universe there exists the direction of time? That is related, all is related, this one. Okay, and before I also go little equation and so on, maybe this concept, again, I want to understand, so Tanaka sensei, that I will ask to translate in Japanese, so you should judge if that Japanese translation is correct or wrong. Okay, say, then you, okay? Can you translate this in Japanese? Invariant of motion. Very important concept. If you don't understand it, then you will never understand my talk or this talk. So you have to understand first the meaning of this word. No? You give up? How about you? Or if somebody can say. Does somebody understand? I mean, raise your hand and don't look that this late afternoon, I will have an interview, and I have to explain some impression of this university student. So you should give the good impression. Otherwise, I might say something or you see that?
Speak loud and confident.
Yes, yes. Don't be shy. Just be more. I mean, you can say aggressive. No, nobody. Because this is the keyword of my lecture. And to understand the Poincaré famous. Okay. You see, it's all right. It's if I have to give really the score of each student, even some student gives a wrong answer, I appreciate your activity. You are more, you see, therefore, I give you a little bit some score. Because even you give the wrong answer, but you try to answer. Okay? So somebody, no? Maybe Tanaka sensei should tell.
運動の効用って常に効用変わらないようにね時間と変わらない
You see, I think look, that even I speak English, actually I understand Japanese. So his answer is a little bit, did you get the little difference about his answer and your answer? You see the Tanaka sensei's answer and your answer. Did you get the difference? Do you understand your answer is very close, but not complete? Why? Which part is not complete? We are talking about quantity. Quantity. It's not a quality. Okay? Invariant of motion is a quantity. Okay. You want to say? No, okay. When we try to describe the motion, we consider phase space. Phase space. Phase space is, suppose there is one particle, then look, there's a coordinate and momentum. That is a one-dimensional case. If there is a two-dimensional case, we have, okay, in one dimension, this pair is called canonical pair, canonical variables. And then the coordinate and the momentum. If, therefore, for in one, one coordinate, the number of the coordinate is called degrees of freedom. So this is 1 degrees of freedom. 1 degrees of freedom has a two variable. That means 1 degrees of freedom, the phase space is 2 dimension. Now, if there is another the direction of the motion, there is another pair. So 2 degrees of freedom, phase space is 4 dimension. So therefore, if there is an n particle, then each particle moving in a 3-dimensional space. Then for particle 1, there is x. Let's go. x1, y1, z1 is the particle, one particle. Then we have px1, py1, z1. So that means this is a 6th dimension. For each particle. Therefore, if there is n particle in 3-dimensional space, we have a 6 n-dimensional phase space. And in the phase space, if you know the point, means you know what is a motion. So therefore, to solve the dynamics is you try to find each degrees of freedom as a function of time. For each variable. And if you get every variable, you means that you finish this. You solve the equation of motion. Okay? So when we say we solve the equation of motion, is we consider usually phase space, in general, multi-dimension. And then in the phase space, the motion is moving, and therefore you follow, you try to get the function. Okay, and this point and this kind of the motion is described by this way. This is called trajectory. Trajectory. I think you know this word, trajectory. And then Hamilton equation of motion is how the trajectory move to determine it.